I welcome you to the first session of Time and Work. In this session, we will take a look at some of the basic concepts of time and work. For example, we will understand work is equal to rate into time and some of the applications of this basic concept. Concept of one day's work. When someone does a piece of work in D days, it implies that the fraction of work done in one day or one day's work can be written as 1 upon D. Similarly, this 1 upon D is also known as the rate of work. If A does a piece of work in 20 days, then rate of A's work or A's one day's work is 1 by 20. If B does some work in 30 days, then rate of B is equal to 1 by 30 or B's one day's work is 1 by 30. Similarly, if time taken by A for doing something is 20 days, then rate of A can be read as 1 upon 20. And if time taken by B is equal to 30 days, then rate of B can be written as 1 by 30. Now we have work is equal to rate into time. Now whenever the work done is not known, we assume that work done is equal to 1. This is an assumption, we could assume any value. But for simplicity's sake, we assume the work done to be one work is equal to rate multiplied by the time required to complete that work. For example, in our case, A requires 20 days to complete the work. So we say work done is equal to 1 unit is equal to rate of A multiplied by 20. Now if you calculate rate of A by simplifying this equation, we get 1 by 20. And that is why when anyone does a piece of work in 20 days, the rate of that person's work must be 1 by 20. In this case, it happens to be A. So we assume that every day A does the same amount of work. This is again an assumption for solving questions in arithmetic. So let us solve one basic question. A does 3/4 of the work in 10 days. How much time will A require to complete the work? Again, we have our basic equation, work is equal to rate into time. Now what is the work done here? The work done here is 3 by 4. The rate is not known, multiplied by 10 days are required to complete 3/4 of the work. So we substitute the values in the equation, and on simplifying we get rate is equal to 3 by 4 into 1 by 10, which means the rate of work is equal to 3 by 40. Now we have seen earlier that rate and time are inversely proportional. Therefore, if rate is 3 by 40, then time must be the multiplicative inverse of 3 by 40, that is equal to 40 by 3. So time is equal to 1 upon rate, that is equal to 40 by 3 days. Let us solve another similar question. A does 6 by 7th of the work in 10 days. How much time will A require to complete this work? To solve, again we have the same equation, work is equal to rate into time. Work done is 6 by 7, which is equal to rate into 10 days. That is the time required to complete 6/7 of the work. 6 by 7 into 1 by 10 must be equal to rate, and therefore rate is equal to 6 by 70. Again, time is 1 upon rate, it is the inverse of rate, and therefore the time required to complete this work will be 70 divided by 6 days. Let us look at another similar example, simple example. A does a piece of work in 12 days and B does the same work in 15 days. In how many days will the work get completed if A and B work together? Now, what is important here is it is not one person who is doing the work alone. Work is being done by A and B together. So it is but natural that their rates should be added. In order to calculate the total rate of work or total one day's work, we need to add the work done by A in 1 day and work done by B in 1 day. Let us see. Rate of A is 1 by 12. Rate of B is 1 by 15. Total rate is rate of A plus rate of B. That is equal to 1 by 12 plus 1 by 15. And the total rate of work is 9 by 60. So once we get the total rate of work, again we follow the same process. Rate and time are inversely proportional. Rate of work is 9 by 60, that is simplified as 3 by 20. We know that work is equal to rate into time. Whenever work is not known to us, we assume the work to be 1, and therefore rate and time are inverses of each other. The rate is calculated as 3 by 20, and therefore the time required will be the inverse of 3 by 20, that is 20 by 3 days. A piece of work in 12 days and B can do the same work in 15 days. A starts working alone and is joined by B after 3 days. How much more time is required to complete the work? So, time required by A is 12 days and time required by B is 15 days. The rate of A is 1 by 12 and rate of B is 1 by 15. The total work is equal to the work done by A plus work done by B. This is not known to us, so we assume that to be equal to 1. So, total work done by A can be replaced by rate of A into time, which you can see we have done here. This is rate of A multiplied by the time worked by A, and this is rate of B multiplied by the time worked by B. We've assumed here that because A joins 3 days earlier, A has worked for X plus 3 days, and therefore X plus 3 days are attributed to A, and since B works 3 days less as compared to A, we say X days are worked by B. So we simplify this equation. We substitute the value of RA as 1 by 12 into X plus 3 plus 1 by 15 into X is equal to 1. On simplifying this further, we get 9x plus 15 is equal to 60, and finally 9x is equal to 45, which yields the value of X as 5 days. So A starts by working alone and is joined by B after 3 days. Now, because the number of days worked by B is also the extra time required to complete the work, therefore 5 days are required, 5 days more are required to complete the work. Let us take a look at another question. A can do a piece of work in 15 days, while B can do the same work in 20 days. A, due to illness, works at 75% of efficiency, whereas B works at full efficiency. Find how much time will be taken by both of them to complete the entire work. And the only difference between this question and the other questions is we are given the efficiency of A as 75%. Let us see how this impacts the question. Again, the time required by A is given as 15 days and time required by B is given as 20 days. Rate of A is equal to 1 by 15. Rate of B is equal to 1 by 20. Now, rate of A1, that is today's rate, is 75% of the normal rate because today A works at 75% of efficiency. Therefore, rate of A1, which is today's rate, is given by 75% of 1 by 15, which is equal to 3 by 4 into 1 by 15. 75% when converted into fractions is 3 by 4 into 1 by 15, which yields the rate of A1 as 1 by 20. Now, when we have to calculate the combined rate of A and B, we use the rate A1, RA1. So let us calculate the combined rate. Combined rate is equal to 1 by 20 for A and 1 by 20 for B, which is equal to 1 by 10. Once we get the combined rate, we can easily calculate the time as the inverse of 1 by 10, that is equal to 10 days. So with this, we come to an end of this session on time and work. In case you have any feedback or any query, please feel free to contact us on studentservices@pfindia.com. Thank you very much.